We've been exploring acute and chronic sleep restriction. Now we are going to look at the less common occurrence of sleep deprivation, losing an entire night or more of sleep. Countless studies clearly show the detrimental effects of sleep deprivation. The most impressive of these accumulated in the latter part of the 20th century. An excellent and comprehensive example of these is found in Broughton and Ogilvy, 1992. Their list of scientifically established negative effects is lengthy and can be mostly divided into 5 categories: negative emotions, cognitive deficits, behavioral deficits, physiological concerns, and psychological problems, with the strongest of all of these by far being negative emotions. Some of the myriad negative documented effects of sleep deprivation are somewhat surprising. For instance, sleepiness usually feels like you are slowing down, but sleep deprivation is actually associated with increased sympathetic nervous system activity, like a racing heartbeat and overreacting. Also, sleep deprivation has been shown to cause increased hunger, increased eating, and weight gain. Many of the effects of sleep deprivation are the result of decreased prefrontal cortex functioning. The prefrontal cortex is involved in executive functioning, meaning higher level functioning, like attention focusing, multitasking, impulse control, risk assessment, decision making, etc. Sleep deprivation increases physiological and manifest sleepiness, but not always introspective sleepiness. Thus, people are often unaware of the severity of their sleep deprivation. Behavioral deficits include those involving psychomotor tasks. The types of psychomotor tasks most affected are long, monotonous, externally paced, newly learned, those requiring memory, and/or those that do not involve feedback. Sound familiar? We talked about this also with chronic sleep restriction and the fact that this includes driving. 17 hours without sleep is equivalent to driving with a 0.5 blood alcohol level. 24 hours is like a 0.10. That's legally drunk in most states. After about 40 hours with no sleep, another effect of sleep deprivation appears, something called microsleeps. Microsleeps are momentary and involuntary pockets of temporary unconsciousness lasting from a fraction of a second up to roughly 10 seconds, ending in a sudden head jolt. What is happening in the brain when we are tired and trying very hard not to fall asleep, but having microsleep? Functional MRI studies showed decreased thalamus activity. That's a part of the brain that regulates sleep, but no decrease in sensory processing parts of the brain. In other words, during microsleeps, parts of the brain check out, go to sleep involuntarily, while other parts do not, and usually wake you up within 10 seconds. Further sleep deprivation can result in even more extreme effects, such as weakening of the immune system and psychotic symptoms, such as delusions, which are false beliefs, and hallucinations. How long do you think you could continue to survive with total sleep deprivation? The mean is 14 days for humans. In this lecture, we've been looking at the need for sleep, its physiology, environmental influences, importance, etc. So Let's conclude with this bathtub metaphor. Wakefulness is like filling a corked bathtub with a constant flow of water over time. The building level of the water represents the sleep drive. Going to sleep is like opening the drain. If the drain is closed before the water completely empties, and that would be akin to acute sleep restriction, you are beginning your next day with residual sleep drive. If this is repeated each time the tub is drained, that would be akin to chronic sleep restriction. You would be beginning each day with a higher and higher level of water, so a higher and higher sleep drive. Eventually, the tub will overflow, causing water damage, just as the ever-increasing sleep debt causes various cognitive, emotional, behavioral, and health deficits. This concludes our lecture on sleep need and sleep debt. Our next lecture will focus on some relatively normal sleep variations like morning and night persons and many other really interesting sleep phenomena like napping and yawning.